Okay, there's two different ways to look at acceleration due to gravity or gravitational field strength. Acceleration due to gravity recognizes that since the force of gravity is proportional to mass and acceleration is inversely proportional to mass, those two factors will cancel out, and every time something is accelerating in the same gravitational field, it will have a constant acceleration that doesn't depend on its mass. See, we have our force of gravity, which is proportional to mass, and if that's our net force, that's got that's mass times acceleration. So as long as the masses aren't zero, the acceleration is always the same, regardless of what mass is accelerating in that gravitational field. Alternatively, we can look at this and say that this is a measure of how much gravity there is in a location. That doesn't depend on what the force of gravity is acting on. So, for example, we know there's more gravity on an object when it's on the Earth than when it's on the Moon. It doesn't matter what that object is. The Earth is bigger than the Moon, so the Earth has a larger gravitational pull than the Moon, which means regardless of what we put on the Earth or the Moon, the gravity on the Earth is going to be bigger. We say then that the Earth has a stronger gravitational field than the Moon. If we go back to our universal gravitation equation, the way to think about this is that a whole bunch of this equation is essentially set as soon as we know that we're on the surface of the Earth. G is a constant no matter what we're doing. If we're on the surface of the Earth, then we're considering the mass of the Earth. And again, assuming we're close to the surface of the Earth, we're going to consider the radius of the Earth. What that means is all this stuff is pretty much constant regardless of what mass this force of gravity is acting on. So we can take all this stuff and we can call it the gravitational field. And that's going to be equal to GME RE squared. And if you did all that in a calculator, you'd see that it turns out to be something close to 9.8 newtons per kilogram. So that's the gravitational field strength of the Earth. Considering this in acceleration due to gravity, again, if I recognize that if I'm trying to say acceleration due to gravity, what I'm really saying is that my gravitational force is my net force. And if I use the large equation for that, I can still see that both of these sides contain the mass of the object. So the mass of the object doesn't really matter, and all of this stuff is also equal to the acceleration that we would expect on Earth. But again, because these values would change on the Moon, we would expect to get a different acceleration due to gravity on the Moon. So let's go through that. Let's see what that actually is. Here's some information about our Moon, the mass of our Moon and the radius of our Moon. So if we say that G is equal to this part of the universal gravitational equation, remember the big equation here, but we want to know how strong this is without looking at what object it's acting on, so we just take that away. Then we can put in our values here. Mass of the Moon is 7.36 times 10 to the 22 kilograms. I just got that off of a chart. radius 1.74 times 10 to the 6 meters squared. So if I put all that in, I've done something wrong. 6.67 exponent negative 11 times 7.36 exponent 22 divided by 1.74 exponent 6 squared. Didn't like it again. Patience here. Sorry about this. There we go. That's what I was expecting. I get 1.62. Now, if I consider my units here, that would be newtons per kilogram. But if I remember that 1 newton is equal to a kilogram times a meter per second squared, then if I take a newton per kilogram, then I can get rid of the kilograms and I can recognize that this is 1.62 meters per second squared. And we can think of this number in two different ways. This is a measure of how much gravitational force I would expect to experience on the moon without knowing what that force of gravity was acting on. Or I can view it as if something was dropped on the moon, what acceleration due to gravity would I expect to see for that object?